3.03, I can rewrite expressions by multiplying binomials and polynomials and use a distributive property. So we've learned sort of two methods to do this. One we called the area model or the box method, and the other way was just by using the distributive property. So this first problem here, I'm going to show it both ways. All right, first way is we're going to use the area model. So we're going to have a 2-term by 2-term rectangle here. So 2x minus 4, I have a 2x here and a negative 4 here. I've got a 5x and a positive 3. So now we just go ahead and multiply to get the area. 5x times 2x is going to be 10. X times x is x squared. 2x times a positive 3 plus 6x. 5x times a negative 4, negative 20x. Negative 4 positive 3 is a negative 12. And then we're going to combine like terms. And the only like terms I have here are in this diagonal. So I've got 10x squared. I have a 6x and a negative 20x. That's going to be a negative 14x. And then I have a minus 12. Okay. All right. The other method that we learned was just by using the distributive property. So when it's a binomial by binomial, I told you it was called FOIL back when I learned it, but that was just a way for us to remember to multiply all the terms. But basically what we're going to do is we're going to take 2x times 5x and then 2x times 3, the first terms and then the outer terms. 2x times 5x, 10x squared. 2x times plus a positive 3 is plus 6x. Now we're going to take the negative 4 and we have to multiply it by both terms. So we have first outer, the inners times the lasts. Negative 4 times 5x, negative 20x. Negative 4 times a positive 3 is negative 12. And if you notice, we ended up with the exact same terms as the box method up here. Okay, just a different way of lining up the problem. So I have 10x squared. These are our like terms, so I have negative 14x minus 12. Same answer. Okay, you could choose whatever method you like. So let's take a look at this next one. 2x minus 3 times x minus 5. I'm going to go ahead and just use the distributive property. 2x times x, 2x squared. 2x times a negative 5. Negative 3 times x. Negative 3 times a negative 5. And now we just combine like terms. 2x squared minus 13x plus 15. Okay. All right. This problem always causes issues because people just try to square this term and square that term. But you will miss some of the multiplying if you do that. This is 2x minus 4 times 2x minus 4 2 times. So I'm going to go ahead and use my box method on this one just to be different. Okay. 2x times 2x. 2x times negative 4. 2x times negative 4. Negative 4 times negative 4, positive 16. Okay. So if I combine like terms, I get 4x squared, negative 8x, that's negative 16x plus 16. So if you had made the mistake of just squaring both terms, you would have ended up with the incorrect answer of 4x squared minus 16. You would have completely missed this middle term. Okay, it just so happened that this number ended up being the same as that number, just with different signs. That's not always the case. This is not correct. Okay, you have to distribute the whole thing out. All right, and last one. Again, you could use any method. I think I'm just going to go ahead and use the distributive property. 3x squared times 8x. 3x squared times 3. positive x times 8, x times 3, negative 2 times 8, negative 2 times 3. Okay, I was very methodical about what I did. I took the 3x squared, multiply, multiply, x, multiply, multiply, negative 2, multiply, multiply. That way you get all of them, or you could use the box method. Now we combine like terms. If you're methodical like the way I did it, the like terms end up next to each other. Right? 9 and 8x squared is 17. 3 and negative 16 is negative 13x. Okay, and there's your answer.